Hey, science peeps, welcome back to another installment of my benchmark lessons. Today, we are going to be looking at Chapter 2, Lesson 3. We're looking at the solar system and all the things that are in our solar system. So hopefully using yesterday's HyperDoc was easier for you, and because everything was on one sheet. Send me some feedback. I didn't see a lot of feedback today, but feel free to send some today over to me or tomorrow. So anyway, let's talk about the solar system. Let's go over some vocabulary since our vocab quiz is coming up on Friday. So first, what is the solar system? Our solar system, it says here, consists of the sun, the planets and their moons, and a variety of other smaller objects that we're going to talk about in a little bit. So the sun is the center of our solar system. And so if you take a look at this picture down here, if you notice, there's this it's like a big spherical ring, if you look at the outermost edge of our solar system. And what's holding all of us together in this orbit around the sun is the sun's gravity. The sun has tremendous gravity. So anything that is not touched by the sun's gravity is not part of our solar system, because solar meaning sun and system. And the furthest part out is called the Oort cloud, which we're going to talk about in a little bit. Okay, so how about another word? An astronomical unit, or we usually call it an AU. An astronomical unit is the distance between Earth and the sun. So one astronomical unit is 150 million kilometers. Okay, so we measure everything by Earth because that's where we live. So if you're less than 1 AU away from the sun, that means you're closer to the sun than you are from Earth to the sun. And if you're more than 1 AU, then your distance from the sun is further away than you would be from Earth to the sun. Let's go do our first activity. It's do the math. Not as hard as it looks. So it says here, to convert from astronomical units, AU, to kilometers, you can multiply the number of AUs by 150,000. Okay, so let's do number one, calculate. So Mars is further away from the sun than we are, so you would assume that its AUs are more than one. So Mars is 1.52 AUs from the sun. How many kilometers is Mars from the sun? So here the direction said, you take your AUs and you multiply by 150 million. Okay, I can't do that in my head. I'm going to do it over here with my handy calculator. So I'm going to put in my 1.52. That's how many AUs Mars is from the sun. And I'm going to multiply that by 150,000,000,000. And the number we get is 228 million kilometers. So that's how far away Mars is from the sun. So you could put that number right down here. Okay, so the next question says, if you know an object's distance from the sun in kilometers, right here we have kilometers, this is Mars in kilometers, how can you find its distance in AU? So we're going to backtrack. Let me ask you a quick question. What is the opposite of addition? Subtraction. What is the opposite of multiplication that we just did here? Division. So we're going to do the opposite of what we just did. We know Mars's distance from the sun is 228 million kilometers. So we're going to divide that now by this number, 150 million. So let's see if this works out. So we have 228 million divided by 150,000. Come on, zeros. 0, 0, 0. And that equals, ta-da, 1.52. Okay, and that's how you go back and forth. You either multiply or divide by 150 million. That's your base number, your key number here. Okay, so moving right along. See, I told you not so hard. Let's go down to our next slide. Okay, let's go to figure 1. And this figure 1, I'm going to turn my page, is on pages 84 to 85. So we're doing figure 1, numbers 1 and 2. So it says the planet sizes are shown to scale, but their distances from the sun are not. So, we're going to talk about this next video, the scale of the universe. And whenever we look at the universe and our solar system, it's never to scale what we see because things are so far away. You never could picture it on one page or in one photo. So they always have to squish everything together. But we'll talk about that tomorrow. But anyway, it says, where is the largest gap between planets? So what I'm going to do is I'm going to go quickly over to nope, not that one. That's the answers. I'm going to go over to your workbook page, but a double page view over here. So up at the top, we have a little scale. And each one of these dashes represents one AU, one astronomical unit. Here's 10. And here's another dark. That's 15 AUs, 20, 25, and 30. So what they want you to do, here's your question. It says, what is the largest gap between planets? Well, in order for us to figure that out, we have to get our planets, look at their AUs, how far away they are from the sun, and put them up here, draw them up here on our little scale up here. So these little data tables tell us information about each of the planets, what we need. So here for Mercury, it says right here, the distance from the sun is 0.39 AUs. So here's 1 AU. And then if you go halfway through, that's 0.5 AU. So we know we have to draw Mercury probably right over here. Okay. So now how about Venus? Venus is 0.72 AUs away from the sun. So again, here's 1. You don't want to draw it there. You want to draw it just a little bit in front of the 1. Put your little dot here, and you want to mark it Venus. Okay. So next we have Earth. We know that Earth, that's our standard 1 AU. So bam, you could just draw Earth right here. So now Mars. Mars' distance from the sun, we just talked about it in our Do the Math, is 1.52 AUs. We don't have to be so precise. Here's 1. Here's 2 AUs. So we can go right in the middle, right here for Mars. Put your little dot here and write Mars. All right, so now let's go to Jupiter. Jupiter, getting further away, is 5.2 AUs. So 1, 2, 3, 4, 5. We could just put a little bit past that and put a little dot here for Jupiter. Okay. Saturn is next. It is 9.54 AUs. So here's 10 and it's 9.5. We'll go in the middle. So here's 9, here's 10, 9.5 is right in the middle. So you can put your little dot here, okay, and write down Saturn. Then we're going to jump to Uranus. And yes, it is pronounced Uranus. The distance from the sun is 19.19 AUs. Okay, so just close to about 19. Here's 20. That means this one is 19. So you could put Uranus right around here, a little dot, and mark it Uranus. And then finally, Neptune. Neptune is 30 AUs away from the sun. It's already labeled here 30, and then put your dot here. So now take a look at your dots and between which two planets is there the greatest distance. Okay, so let's go. I'm actually going to go take a quick peek over here at the next page because this has all the dots here for you. And as you can see, between Uranus and Neptune, it has the greatest distance between them. So, when you have our inner planets, look how close together they are. Mercury, Venus, Earth, Mars. I know Mars is a little bit, where's Mars? Oh, right here, a little further, so they're all pretty bunched up together. And then once you start getting out here to the outer planets, they're really distanced far apart. So then I know it's already showing the answer, so I'll leave it up. It says, could you show the planet's relative size and distance from the sun on one page? Well, obviously, this is 2 pages and everything is so teeny tiny, these little dots, and it's still far away. So you couldn't show them to scale on one page because it's just so tremendously far away. And again, tomorrow we're going to go into more detail with that. But when we look at pictures, even in our book that you see here, these are not to scale at all in any way, especially the distances that you see between them. It's just space is just so vast and there's so much. That's why we call it space, because there's lots of space between things out there. All right, let's move on to our next activity. Let me click here. Okay. And our next one, let's talk about some more vocabulary, a planet versus a dwarf planet. So what's a planet? When you remember, I know when I was growing up, Pluto was a planet and it's not considered a planet anymore. It's considered a dwarf planet. So let's find out why. Why was Pluto downgraded? Poor Pluto. All right. So it says a planet right here. Okay. Must be round, orbit the sun. So it has a regular orbit, as you can see here, going around the sun. And it must have cleared out the region of the solar system in its orbit of any debris. So if there's debris in the way, it's not considered an official planet. Okay. So you can see here Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune are all official planets. They all meet these three criteria. Now let's go to our next slide. What's a dwarf planet? What's the difference here? For a dwarf planet, okay, so it has to be spherical. So here we see the word gravity here. So gravity is what pulled together the debris in space to form these spherical objects that we call planets or moons, okay? But the planets, so that's why the inner core of planets are more dense than the outer surface because it has a more mass to it. So that was pulled in toward each other due to gravity first, and then it formed these spherical objects. And then the gravity of the sun took over and it formed an orbit around the sun. So you'll see some dwarf planets that are kind of like not really round, they're oblong. When we look at the dwarf planets, we'll see one of them is like that, but spherical, roundish. Okay. But here's the thing. So it also has an orbit, a regular orbit around the sun. But then here is the third criteria. Why is it not considered a planet? Because it has not cleared the area of its orbit of debris. Okay. So we have five official dwarf planets, and we're always finding new dwarf planets all the time. So probably by the time your kids are in school, if you have kids, we're probably going to have like a slew more of dwarf planets out there. So anyway, the five dwarf planets that we recognize right now are Pluto, Eris, Ceres, Makemake, I love saying that word, and Haumea. Okay, so let's take a further look into the planets. This is our next activity, assess your understanding, 1A. So it says list the planets in order from increasing distance from the sun. So when I was in school, we used my very educated mother just showed us 9 planets. That last P for Pluto, I can't use that anymore, but it still helps me. Okay. So if you actually go back to your book and look on pages 84 and 85, right over here, right, it shows you the order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Right there. So it's right on the page above where you have to write that. Okay, so once you've written that down, let's go on to our next. This is assess your understanding 2B. So this one says, what is the relationship between a planet's distance from the sun and the length of its year? So I made a data table here for you. Data tables, we use them in science all the time. They're a good way to analyze data and make connections. So here I wrote the name of all the planets, and then I wrote their distance from the sun in astronomical units. And all of that I got from pages 84 and 85. Okay. So I did some research. I Googled it. Okay. It wasn't hard. I love Google. And I just looked up the length of these planets' year compared to Earth. right? Because in that one AU, that's what we compare everything to in astronomical units. So we're going to compare this to a year on Earth. So ED in my data table means Earth day. And then we go down to EY, that means Earth year. So let's take a look. Mercury's first. One year on Mercury. So the amount of time it takes for it to go around the sun is 87, almost 88 Earth days. Okay. If you're on Venus, it takes 224.7 Earth days. That's one of its years. We know Earth is 365 days. And I'll take a look. See how it says that 0.26? This is why we have leap day every 4 years, because a year on Earth is actually 365 with a little change after it. So there's a little quarter there after it. So 4 quarters equal 1, so that we have to add 1 extra day every 4 years. And that's the reason we have our leap year. Okay, so look at Mars. Mars, 1 year on Mars is 687 Earth days. Okay, almost twice as long as what we have here. Now let's jump to Jupiter, because we know Jupiter's a lot further away. We have a big jump when we saw that in our other activity. 1 year on Jupiter would be 11.86 Earth years for its one orbit around the sun. Saturn, even further away, as you can see here, it's 29 and a half Earth years. That's 1 year on Saturn. Uranus, it takes 83.75 Earth years for Uranus to make one orbit around the sun. And then finally, Neptune, 163.72 Earth years. So what do you see? The further away a planet gets from the sun, what happens to its length of year? Its length of year increases too. So that's the relationship here. The further away the planet is from the sun, the longer it takes to go makes one orbit around the sun. That makes sense, right? Because there's more distance to travel. Okay, let's talk about another vocab word. These are planetesimals. So when the solar system was forming, there was all kinds of debris floating around, and gravity pulled those denser materials, like I said before, into the center of the planets. That's why we have dense cores and then a thinner crust, a thinner outer surface. So when all the planets and all the moons formed, and we're still discovering new moons every year, Jupiter's and Saturn's moons are increasing all the time. There was some debris left over, some that maybe wasn't dense enough or too far away from each other to really pull together. And it was this leftover stuff that's floating around out in our solar system right now. And we call those planetesimals. That's all they are. All right, so speaking of the beginnings of our solar system, this is figure 2. We are going to write the numbers 1 through 4 in order from looking at these pictures. Which picture do you think is the youngest picture of our solar system, and which one is the oldest picture of our solar system? So if you know a little bit about space, we have these nebulas out in space, and these nebulas, some people call them nurseries for stars. And how stars form is that there's bunches of gas and debris out there, hydrogen gas, helium gas. And over time, gravity pulls in the debris and the gases, and it forms the stars. So looking at these pictures, which one looks like it has the most amount of gases and debris in it? And you might guess it's this top picture here. So this is the youngest picture of our solar system, number 1. So now we go to things are starting to form. You can almost see a sun forming in the center of this thing. And that picture would bring us down here to number 2. You can see there's this bright spot in the center of the solar system. So that would be our sun. Okay, very young sun, but that's our sun. Now, moving along in this next picture, what do you think is the next order? You can kind of see now orbits starting to form for some planets. And that one would be here. So this would be number 3. Still lots of debris. Probably this is a time where Earth and Moon and all the planets are bombarded every day by meteors. And that's why we have craters, and all these are moons and planets. and that was no life existed yet in the solar system. And then number 4, this is what we look like today. So you can really see we don't get a lot of collisions anymore from meteors. I know people talk about that all the time, but take a look at it's really been cleared out over there of all those debris. So we don't get a lot of collisions often from meteors or meteorites. Sometimes you'll see shooting stars, but it's just tiny particles that break up in our atmosphere. So it's lucky we're an older solar system, so we don't have to worry about that so much. All right, let's go to our next activity. I believe this is our last activity. Assess your understanding 2A and 2B. So 2A says, what force formed the solar system? Again, a recurring theme since the beginning, since our forces book. What's that big force that we're always talking about? And if you haven't guessed it already, it is gravity. Gravity is the big force that is controlling all this. And then 2B, why are objects in the solar system different from each other? So if you look through your book and if you read the pages here, we have our inner planets and we have our outer planets. The inner planets are Mercury, Venus, Earth, Mars, and they're called the rocky planets. So they're more dense, they're smaller too. The outer planets, Jupiter, Saturn, Uranus, Neptune, they're called the gas giants. They're further away from the sun. So gravity wasn't pulling on them as much. So they were able to be larger in size and be more gaseous. Yeah, they still have some kind of core in them, but they're so large and they're different because of its placement, their placement in our solar system. So the further out you went, the less pull of gravity, so the less dense they were. And that's a very interesting fact. All right. Whoops, I went ahead too far. All right. So before we move on to that slide, I would like for you to take a look at this video. Pause me, please. Go back to your Google Classroom. And I would like for you to watch this very quick 4-minute video about our solar system from National Geographic. And then come on back to me when you've watched that. All right, one final slide I have here for you is it says, can you find the planet? So there was an article I gave you the option to read yesterday. It was if you were bored at home, some things you can do to be a at-home scientist. I think one of the things was you can count penguins for scientists. Another one was, can you find a new planet up in the sky? There was a 17-year-old boy who did that last year. So how do you even discover a new planet? How does that even happen? So scientists have to do a lot of watching and waiting and have to be very patient. And the way that you discover a planet is, well, stars don't move. Stars stay in their place, but planets move. And so if you're watching an object and you see it moving and it's moving in a regular pattern, and then it comes back to that same spot at a certain time of year, it depends, I guess, on how big that orbit is. But you see a regular pattern in its movement, you can pretty much assume that that is a planet. So here on this picture, it's a GIF, so it's going back and forth. It's looping right now. But can you spot the planet in this picture? Take a look. Do you see anything moving here? And I'm going to show you now. There it is, right there. Okay, so you would have had to watch that though. It's probably going to be moving and going around in some kind of regular pattern. But that's how you discover a new planet, by watching and waiting and being patient. Okay, so let's go back to our hyper doc here. So we just completed the walkthrough and these activities. The next activity I want you to do is I want you to read this article, What is a Planet? And then watch this video. This is an 8-minute video. It's a guide to dwarf planets, it's called. So you're going to learn all about the dwarf planets, and there's a Google form that goes with it. I try to make it easy for you. Here's the Google form. Okay, we're going to learn about these dwarf planets. So you put in your information, and I made them all drop-down boxes. So you pick your answer by selecting the question in the drop-down box. And then we also here I separated it by planet. So we're going to learn about Ceres and oopsies. So you see here that there are 4 blanks, A, B, C is over here, and then D. So as you're listening to the video, I have A, B, C, and D all here. So you pick the one that where all the answers fit correctly into these blanks. Okay, so you're only selecting one of these 3 choices. Okay, here's a hint. It's not that one. So then we have Pluto. Okay, and the same thing. There are an A, B, C, and D. So pick in your drop down box the one that is most that sounds most like the right answers from the video. Yep, that's me. So we have Eris, Haumea, Maki Maki, my favorite one, and then we have some other questions here. Okay, so going back to our HyperDoc, another thing for you to look at is, and I think this is fun, the Pluto debate. Obviously, Bill Nye loves Pluto because he's saying it and he's screaming it. So anyway, so 2006, Pluto was downgraded from planet to dwarf planet. So there are 2 articles here that I would like for you to read. Just peruse them. You don't have to read them in depth, but do some reading about it because I want you to cast a vote and I want you to cast an educated vote. And the way that you educate yourself is by gaining knowledge. So there are 2 articles here about whether Pluto should be made a planet again or remain as a dwarf planet. So if you could select one of or read both of those articles, and then you're going to cast your vote. You're going to click this link here, but I have it up already. And it says, should Pluto be voted back in as a planet or remain as a dwarf planet? Cast your vote. So you just have to select yes or no. This one is not required, but if you want to write down why you think so, go for it. So cast your votes, and on Friday, I'm going to tally up those votes. I will tell you what our class decided. Should Pluto be a planet again or stay a little dwarf planet? Remember to study for your vocab quiz using Quizlet later this week. And then finally, this is optional, but again, if you're really excited about all of this, I have this website here. This is the website where you read that first article about planets. So I'm going to take you back to that website. Okay. Here you read that article, What is a Planet? But what's really cool about this website is if you click this option right here with all these planets moving around. It's going to take a minute to load, but it gives you a view of the solar system. It tells you the time of day. Yes, you can see when I'm recording this now. But what you can do is you can zoom out and in on the solar system, but you can come in here and search anything, any moon, any planet, even the probes. We have Voyager 1 and 2 right now that are moving through. Actually, Voyager 1's way out there. I'm going to search Voyager 1 real quick. VOY right here. Voyager 1. And it gives you a little description of whatever it is that you're searching for. So Voyager 1 is the furthest human-made object from Earth. It is going out towards the Oort cloud, which I didn't tell you about yet. That reminds me to tell you about that. But it gives you some information about it, which you could read here. I can go ahead and search Jupiter. Oops, I spelled that wrong. We should try to spell Jupiter correctly. And it zooms you right in on Jupiter. And you can then take a look at different facts here. It tells you the astronomical units, how many moons. We're up to 79 now. I think your book said 60 something, so our book's out of date. Tells you the length of the year. But anyway, this is a really, really cool site for you to look at. The other thing, and I know we're all interested, and maybe you don't know this, is that all of the outer planets have rings. Yes, Saturn is not the only planet with rings. Jupiter has rings. Uranus has rings. Neptune has rings. Jupiter's rings are so small that when one of our probes were passing past Jupiter, that's how we actually were able to see them. So I have a video and an article. You don't have to look at them. You can just look at the videos, one or the other, if you want to learn more about that. The one thing I meant to tell you about was, let's see if I can find, oh, here it is. Okay, the Oort cloud. Okay, so the furthest out our solar system goes is to something called the Oort cloud. And it's this cloud of planetesimals, of just this debris that's out there. And We usually think of things in two-dimensional, like just like a ring or something, but really the Oort cloud, if you think about the sun, and the sun is a sphere. So its hold of gravity is spherical. It's in all directions. It's not just linear. It goes in all directions. So if you were to stand way back outside of our solar system and look at it, you would see that we are surrounded by this cloud of planetesimals of debris. And this is the furthest reaches that our sun has on, that its gravity has on objects. So that's why we call this the Oort cloud. It's just a cloud of debris. And I just thought that was a really cool thing to look at. The other last picture I want to show you, because you're probably sick of me talking, is that with Jupiter, Saturn and its marvelous rings. Well, sometimes the moons of Saturn either go through the rings or have a path in the rings. So this is one of Jupiter's moons, Daphnis. And you can see as it moves through one of the gaps in the rings, it makes these waves. And then after it passes through, the gravity of Saturn calms down those waves and it gets straight again. But these are amazing pictures here of, here's a further away shot of the moon traveling through one of the gaps in Saturn's rings and all these waves that it's forming. And I can put this article up for you too. Look at that shadow that it's casting. It must be pretty big for it to be casting that kind of a shadow. And then even the wave in the rings starts to cast a shadow. So I thought this was a pretty amazing picture that one of our probes going past Saturn took. Look at that. Look at that wave right there. Because these rings aren't solid. They themselves are made up of tiny particles and dust and debris. And some of them are bigger chunks, but some of them are really tiny things. So anyway, that was a pretty amazing picture that I think I'm going to end with today. Okay, if you have any questions, Google, text me in Google Classroom, send me emails. I will put this article up there too on our HyperDoc if you want to take a look at that. And that is all I have for you today. So, CG out.